Nou, als ik voor de camera ga staan, denk ik. Oh, hallo. I will be giving this presentation in English because one of our members wanted to follow this, and yeah, it doesn't really matter to me. Welcome. For those who don't know me, I'm Erik. I am an embedded software engineer. I've been in the field for over 10 years. I worked at Alliander, Locomation, DigiT, and I currently work at a company called Cool. And my job is basically making very difficult pieces of software that runs primarily in chips. Today I'm giving a course about KiCad, how to get started. Most of you will probably not understand how these things work, and I hope at the end of today you might grasp a little bit of the idea how they function. KiCad is open source, which means you have access to the source material. If you want to make a change to the program, you have the option. For me, personally, you have closed source projects, which are primarily backed up by companies. And at the end of the day, for me, personally, it always feels like all of those projects are always, at the end of the day, to make money. Open source projects feels for me that is primarily made by the user for the user. And at the end of the day, open source projects are usually, it's my feeling, for the user. There's no monetary gain to be had here, other than the primary goal for this is to make software as awesome as possible. Reason I use KiCad is actually a monetary one. I'm a software guy, which do happen to know a lot about hardware, but it's not my primary job, which means I have to take a look at it, a peek at it sometimes, and that might be 5 minutes a day, might be 10 minutes a day. It's not my full-time job. So if I want to work in Eagle, 70 euros is about 800 euros a year. That's a lot of money for something you look at sometimes. Altium is out of my price range altogether. It's a very professional piece of software, and if you do it full time, then it might be worth it. I hate monthly subscriptions anyway. And you have KiCad. KiCad is open source. It has actually quite a bunch of nice features that I use, and it's completely usable. And one of the things that actually happened to me is one of the old projects at a company I worked at had one project in sprint layout 6. And I only needed to know how the schematic was built. That's all I wanted to know, just to take a look at it. But you have to have a license for it, and therefore you have to buy it just to take a look at it, which is a really annoying step up for me. I also used multisim and ultiboard in the past in my study. It's actually quite nice. There's some nice simulations. It has auto routing, all kinds of features, but it's not maintained, so very old. Software can still work because the design process hasn't really changed over the years. Still being made on the same way. So if you're used to KiCad, you can most likely use multisim and ultiboard, and you can probably also work with Eagle. Altium, I actually don't know. Too expensive for me to even try. That's not one that rings a bell with me. I can't try every piece of software. Okay. This is a beginner course, so I'm actually going to dumb it down quite a bit. And in order for you to understand how all of it works, I actually have to take you guys back to a little, actually long back. Who remembers these pinball machines? Who's ever played with one? Yeah, a really old one? Yeah. Yeah, these things are amazing. They're actually quite amazing pieces of technology because they were all built from hardware. The bottom side panel looks like this. You have a wooden board with all kinds of components wired together. Sounds familiar? Looks familiar? A little bit. But this is not only motors and sensors. This also contains all of the logic of the entire device, which isn't only limited to the flippers, which is also includes the score counter. The score counter was a physical device with all kinds of radars and motors, and I can basically talk for like 2 days about this machine alone, and you wouldn't still understand it. Just Google a pinball machine diagram and have fun with that. No, but it's still on my to-do list to actually build one of them, but then in the modern sense. So yeah, you have all of these this logic as well, which includes the lights, score counters, and sounds. And it was fine for that technology, but nowadays we have chips. But what happens if you have enough of this technology and you put it all into one room and you hook it all together? You can actually make a computer. This is the first computer. It was the size of a building. A little bit sad that your laptop is probably more powerful than an entire building together. Well, this thing probably also uses a lot more power, but still. But it can do 10 calculations a second, in theory. Your laptop can probably do millions. Just to give it a little bit of an ID. And that all happened thanks to this component, a transistor. This is a very basic component. You give energy at B, and a current starts flowing from C to E. That's it. Very basic component. But if you add two together, you can make logic happen. This is a NAND gate. Those from an electric engineering background will probably understand what a NAND gate is. An AND gate is the same one, but the out is over here. So you can make different kinds of logic gates depending on how or what. But if you add 4 of these together, you can make a T flip-flop, which is equal to 1 bit. You suddenly have the ability to remember stuff. Put 8 of these together, and you can save a byte. Put this in a chip, and you have the ability to save memory. You suddenly have a memory chip. And if you add a couple of AND gates, then you suddenly have an 8-bit counter. This is how chips are created, and the manufacturing process is being made in such a way that you can easily use those chips in PCBs. But there's also a thing called Moore's Law, which states that every 2 years, the amount of transistors on the same surface area doubles. Hasn't been proven wrong. The last one is 2020. We'll see where it'll hit the ceiling. But the chips that we have become more intelligent over time. We have the ability to put more logic into the same size chips. So we already have a lot of different kinds of chips and OR gates. If you just go to Google and just search for IC AND gate, you will probably just find millions. Different kinds, different suppliers. You can also just search for an IC 8-bit counter. Same thing. Which one is usable for you? I don't know. You also have very intelligent chips, which you can actually program. They are of such an intelligence that you can actually convince it to run a program for you or to emulate the hardware. And they come in 2 flavors. FPGAs, they primarily act as hardware, and you have a microprocessor which runs software. You can actually run a program. And the main difference is this: if you give 10 lines of code, everything happens all at the same time. And if you give a microprocessor 10 lines of code, everything happens after each other, but really, really quickly. So all of the logic of a pinball machine, you can basically move towards chips. And but you still need sensors, you still need motors, you still need LEDs. You need the chips for your logic, and you need a way to wire everything together, because the photo I showed you from the bottom side of the pinball machine, it was like 1500 wires. You do not want to hand solder something. You want something that you can just order from the assembly line, have a PCB with connectors, you plug it in, ship it. Final product. So let's get started. Yes. If you move all of the logic to software can crash, software can hang. So if you have a system, for example, a closed water loop, it can heat it up. You also want a system to turn it off if the temperature reaches a certain height. Same thing applies to electronics. If you can make a security loop in electronic hardware as well, you probably would want that as well. Not all of the logic you can move towards just chips. So what's your ID? Everyone here is probably, there's some kind of ID he wants to work out. You can make a giant Clippy, Microsoft Clippy with red eyes, or you want to make a keyboard, one of these things, for example. PCBs. You got also PCBs to help you do all kinds of things. So whatever ID you have, what you're here for, you probably first want to get, will it actually work? So you start with phase 1, which is prototyping. This is an Arduino Uno, been around for a long time. Most of you probably know this one, which is a prototyping board for this microprocessor. The only thing that's actually usable, well, for your final product is the microprocessor, and the rest around this is just so you can easily put a program on top of the chip and power the chip. And lastly, to connect it to your own project. You take a bunch of wires and baseboard. You can plug in motors, you can plug in sensors. You can just make diagrams like this happen relatively quickly. You can make this under 2 minutes, probably with this and a bunch of wires. When you're done prototyping, when you finally have hooked this up to all of your different sensors, to all of your different LEDs, displays, whatever your ID might hold, you will probably end up with something like this. This is actually from one of our members here. He's called Luke, and he actually made a keyboard with all kinds of push buttons hooked up to a Pico. He actually had problems powering this thing, so I helped him out a little bit. But yeah, it's a nice product. He can use it. The buttons work. If you plug it into a laptop, you can press it. It's functional, but this is not something you would want to make 1,000 times. Something like this would easily be made from a PCB the size of roughly the same board. Make holes for the buttons to flow through, and maybe you might want to add some soldering points here to connect it to the baseboard. You have these lengths pieces of wire. Probably a better way to do it, but that's my idea on it. But even still, this thing, it's beautiful. It's a working product. It's the final prototyping, but at the end of it, you should have a working schematic. I mean, the keyboard works. The keyboard functions, so you know the schematic is functional. And you should have a working list of logic chips and its components. Which chips did you use to get to a working keyboard? Also, shout out, if you want to get started on prototyping, there's another course here which helps you get started with Arduino with these things. And the same logic also applies to different microchips, except you might need a different programmer, you might need a different prototyping board. depending on what you want. These ones have been around for ages. They're really, really simple, amazing for controlling LEDs, switches, whatever you want. And they also come in different sizes. This is a Mega. Larger brother of this one, also been out. There's 100,000 to choose from, and they're all differ in intelligence. Once you're done with this, once you finally have figured out what your product actually needs, you can start working on designing your PCB. And that's what this course is about. So the first thing you have to do is install it. I have one installer on a USB stick. Has anyone installed it on their laptop before coming here? Okay, cool. Then we can get started. First thing is always to create a new project. Give it a nice name. It doesn't really matter what. You can work with, and I'll wait a minute. Livestream nog oké? Veel mensen kijken? Have KiCad installed? Ah, perfect. In preparation. If you have installed it from an app store or something similar, make sure that you also have the libraries installed as well. For Arch, is that a separate package? Arch Linux. The default libraries. You have a footprint library, a symbol library. Not sure if there's a third one. Yes? Well, if you create a new project, you have a PCB file and you have a schematic file. We need to tell the program what schematic we want to make. So we're going to open that up and we're going to add components. You can press A and mouse click anywhere. It'll open up a dialog. I'll basically ask you which component do you want. We can search for Uno. You have several to choose from right here. I'm not sure if this is the R2 or the R3. This is just one I grabbed from a bin. I think this is the R2. And make sure that, take a note that at the bottom right, you have a footprint editor. You can change this later, but for now, you can just select one of which, and you can select one that looks like one of yours that you actually want to use. Once you've selected it, you can place it down somewhere with mouse click, and you can rotate it for R. You can basically keep adding all of your components in. Oh nee, ik klik gewoon hier. Ja. Wacht even, ik klik eens gewoon linker muisklop. Ja. Links, gewoon even hier. Ja. Ja. Kan ik hem hier zoeken? Ja, bijvoorbeeld Uno, iets. Ja. Dan kan je hem ergens plaatsen. Lukt het?
Toch? Dan kan ik gewoon eentje uitkiezen.
Ja, ja.
Laten we die maar als laatste.
Dat kan. Nee, je kan gewoon je eigen ding doen als je wil. Hoeft niet per se deze te zijn. Het is voornamelijk gewoon dat je een cursus is vooral om je een idee te geven hoe of wat. Make sure that you have footprints selected. If you double click on the component, so resistors are a bit thing. You don't have a footprint selected. If you double click this one, yeah, click again. No, just click away. Okay. Yeah. Select a footprint. There's also something worthwhile to note that if you have separate, if you want to make a nicely ordered schematic, you can add labels to things. They connect things from one schematic to the other using labels by pressing Ctrl and L. You can also add things like ground to make things easier to connect. And the background all connected, but for now that is fine. I have added in this this course just a simple resistor and an LED, just to keep it as basic as possible. You should have end up with something like this. This represents my Arduino Uno. I'm going to make a shield for it, and I've attached a resistor and an LED to ground. And just to make sure, I've also attached one ground symbol to the ground of the Arduino, just to make sure. Wat een beetje lukken?
Ik ben alleen even aan het kijken, die standaard, dus gewoon de standaard analoger bouwblok.
Ja, nee, precies.
Dus alleen even de vraag.
Als je de resistor zoekt, gewoon R. Dat is heel gemeen, hè?
Oh, gewoon als default.
Nee, gewoon wel A. En dan gewoon zoek naar R. Ja, resistor.
Ah.
Dat is echt een hele gemene, I know.
Ik zit echt te denken, je hebt gewoon verschillende wattages en niet verschillende groepen.
Wat wel zo is hier rechts kan je een footprint uitzoeken.
Daar is dan gewoon in feite gewoon de footprint tussen de wattages en dergelijke.
Ja. Nee, welke specifieke component je zoekt maakt hier eigenlijk nog niet eens heel veel uit. Het gaat vooral om welke grootte je hebt, zeg maar.
Ja, precies. Dat is wat ik in het verleden... ik wil vaak gewoon op een gegeven moment iets weten. Het is wel goed voor schema's.
Ja.
Lukt het maar dan inderdaad de vertaling met de footprints.
Lukt het thuis? Ik ben daar hele dingen aan het maken. Niet. Dit is de schema editor. Nee, oké. Je hebt ja, hoe je dit autoroute. Er is waarschijnlijk een autoroute plugin. Ja, om eerlijk te zijn, ik zou gewoon beginnen met dingen aan elkaar te knopen. Ja, gewoon niet te veel over nadenken. Het ziet er heel uitdagend uit. Is het niet? Nee, ik kom zo op dat punt. Maar goed, dat je net weet. Wat zijn dit? Dit zijn...
Oh jee. Dus dat voorbeeldje wat je gaf met die controller. En letterlijk een eigen controller aan het maken.
Ja.
PlayStation 4 controller als wireless module.
Ja.
Daar ga ik allemaal de knopjes aan. En in plaats van die plaatjes allemaal los te solderen eraan. Maar
Ja, nee, precies. Als je niet vaste connectors hebt, je zou ook één grote connector kunnen nemen als dit, zeg maar. En al die dingen die je vast kunnen maken.
controller die dus allemaal knopjes aan een socket hebben hangen.
Ja. Yes. Looks good. Did you select the footprint for all of the components? Yeah. Yeah. Yeah.
Ik zou graag een keertje wat met FPGA willen doen.
Mhm.
Kun je me wat aanraden? Wat simpel genoeg is om mee te beginnen. Ik heb eens een keer een PCB'tje gemaakt in Easy 1.
Koop een MCH-badge van Renze voor €35. MCH-badge. Badge als een B-A-D-G-E. Ja, enter. Klik hier maar op. Renze heeft een deeltje. Deze dingen zijn een hele leuke... het is echt een Game Boy, zeg maar. Die was bij een hacker-event... werden die verkocht.
Ja.
Als je meedeed, kreeg er een. Je kan er nu ook eentje loskopen en daarmee financieren ze de volgende batch die ze gaan maken. Okay, hier zit een FPGA op, hier zit een ESP32 op, full color display.
Ja.
En hier zijn ook heel veel guides voor geschreven hoe je ermee kan beginnen met FPGA. Ik heb er een programma voor geschreven die de zaklamp app heet en die zet die ledjes aan.
Ja.
Het scherm om volledig wit en dit ding hangt dus aan FPGA.
Ja.
Dus ik heb een FPGA bytestream moeten maken om dat ding helemaal uit te zetten.
Een standaard led, zeg maar.
Ja. Je hebt hier ook allemaal guides voor en zo.
Ja.
Goed, als je met FPGA programmeren wil beginnen, dat zou ik dit aanraden.
Hier zit ook de controller. Dus,
Ja. Ja, nee, je kan hier van alles mee. Maar goed, dat is, als je met FPGA wil beginnen, zou ik hiermee beginnen. Of Verilog of VDL proberen te leren. Dat vereist dus een beetje een andere gedachtegang, want alles wordt dus tegelijkertijd uitgevoerd. Als jij iets tijd-based wil doen, moet jij dus een kloksignaal in je diagram inbrengen.
Ja.
Om dingen dus sequentieel te maken.
Ja.
Dit moet ik even vragen straks. Ik denk dat we er hier wel eentje hebben liggen.
Oké, vet.
Okay. Everyone ready so far? So a little bit of information. The footprints that you select on the bottom right depends on what kind of a component you have. You have three kinds of components. And at the end of the next slide, I hope you understand these boards a little bit. You have through hole, which are like actual drill holes through the PCB. You plug in a component and you can solder it on the other side. It goes through the entire board. You have surface mounted devices, which basically just lay flat on top of it and are also soldered to the pads on one side. Microchips is a very popular one. You also have like ball pins underneath, but I don't recommend those to beginners. That's a little bit advanced to get those soldered. These ones you can still hand solder. If you're going to pick a component for your diagram, and you need a resistor, for example, very simple, you have them in different sizes. This is metric, this is imperial. If you're going to pick one and you're new, don't pick the smallest one, thinking, oh, I can make it as small. Go for at least I believe it's this one, 0805 is still very easily to be hand soldered. If you go for or for the smallest one, 0402, it's the size of a grain that sticks to your soldering iron, that sticks to everything else except the place that you want it to. And the moment you sign from frustration, it gets picked up by the wind and flown off to a distant land somewhere. Do not pick the smallest one if you're starting out. You can hand solder them. I know people have, but it's primarily bragging rights. Yes, hello. You of course also need a way to attach external devices to your PCB, so you also have connectors. You usually connect your external device to a male, and you primarily solder things to the PCB, which is female, but the other way around can work as well. It depends on what kind of connector you want. There isn't really a bad way of selecting one. These ones are actually really popular because it's compatible with proto pins. For example, these ones. Just pin headers. And there's not really a law that states which one you can use or which ones you can't. But use default connectors. Don't try to make your own connector. Just use a default off-the-shelf item that you can just order from Fresnel, Mouser, or Arrows Online. But do not misuse these default connectors. For example, USB-C. There's a standard about it. Do not put 50 volts through a USB-C connector. Sounds nice on paper. Oh, a default connector. We can totally use it until someone plugs in their phone charger. Don't do it. The same thing with RJ45, which you know it as the internet cable. There used to be a company that actually supplied about 220 volts through a cable with an RJ45 connector at the end of it. Every machine is a smoke machine. If you operate it wrong enough, well, there's a reason those devices aren't in the market anymore. It was a fire hazard. If for some reason you find a component online and it's not in the default library, which you all have installed, luckily. I haven't seen anyone having issues with it before. Most of the time you can download the symbol and the footprint from one of the stores, and you can add it to your library. You use that with the symbol and footprint editor. They're also in KiCad. They're let me take a peek. They're over here, footprint editor, and you've got a symbol editor. And with those two, you can basically make your own device. If you can't find one online, just find a default footprint, copy that one over, make your own clone, and just change the data of what every pin does. It's way easier than to try and build everything from scratch. So, yeah, you should have something that looks like this, some kind of circuit, something that tells the program what is attached to what. This is the logic. And then becomes the puzzle, how do you translate it into a board? And that's actually a puzzle. This is one of the famous ones. You have to connect the three houses, the gas, water, and electric, without crossing it. And most people come to this point, where you can't supply the third house with the third resource. And there are ways around it. You can trace it underneath the pad, underneath the component. It's a valid solution. But a PCB is multi-layered. You can also go underneath one of the lines and up the other side. It's also possible. It looks really spaghetti, but that's where the program comes in. Let's just for now start off with just a really simple 2-layer PCB, which contains just a core, which is mostly plastic, copper on each side, followed by, well, manufacturer a solder mask, so your components will actually be able to get soldered to the PCB once you place them, and a silk screen, which is just, let's put the entire plastic device underneath the printer and just print ink on top of it. Don't put things on the silk screen that conflict with the pads you want to put your components on. Don't make those overlap. It's really important, because if you have printer ink on top of it, your component won't be soldered properly. If everyone got as a diagram like this, you can open up the PCB editor, which is the other file we had, and you can go to tools and then say update PCB from schematic and hit update. It'll draw in the schematic, all of the footprints that you've selected, and dump it on top of the file somewhere. Niet duidelijk? Oh ja, nee, er zullen vast wel andere shortcuts zijn. Ik weet ze ook niet allemaal. Lukt het?
Volgens mij moet ik hier nu een component aankoppelen. Anders dan staat er niet wat de footprint is.
Oh, dat. Open een schema is. Ja. Open een schema is.
Ja.
En dan dubbelklik is op component. Dan heb je hier footprint, die is goed. Dus deze cancel.
Ja.
Klik eens op die bijvoorbeeld. Die heeft geen footprint. Klik daar eens op.
Okay.
En dan heb je hier een library dingetje. Ja? En dan kan je hier eventjes een footprint uitzoeken.
Dus dit is bijvoorbeeld een...
Nou ja, dit zijn alle footprints. Ik denk dat je even moet filteren op R. R van resistor. Ja, precies. Die. Geen idee. Ik denk dat de pad misschien iets groter is of zo. Kan. Ik denk dat als je ze selecteert met Ctrl. Ja, en dan rechtermuisklik properties misschien of zo. Ik weet niet hoe je kan mass editen, maar het zal vast wel een ding zijn. Je kan sowieso, het is een tekstvlak, dus je kan sowieso gewoon kopiëren en plakken. Als je die oude opent. Dat is altijd het puzzelen, Thijs. Voor welke?
Voor alles. Zoals hier voor onze kofferzeetjes.
Ja, zoals ik zei, ga niet voor 0402. Ga voor bijvoorbeeld 0806 of zo.
Nou, ik zal gewoon deze rol kijken.
Mhm.
Waar is het niet gelegen? Zo.
Dat is een standaard tool.
Een standaard?
Standaard tool. Gewoon
Gewoon een through-hole.
Gewoon zo'n pinheading?
Je kan een testpoint gebruiken. En je kan een 1x1 header gebruiken. Zoek eens naar 1 keer 1.
Wat zeg je?
1 keer 1. 1x1. Zo. Die bijvoorbeeld is 1 keer 10. Is het niet 1 maal 1 of zo?
Had ik dus straks ook nog even. Ik had wel als een soort.
Ik denk wat jij zoekt is testpoint bijvoorbeeld of zo. Of een...
Ja, inderdaad. Dat is beter. Oh, ik heb het wel nodig. Oh, oké.
Kom jij er een beetje uit?
Enorme lijst aan opties.
Ja, dat klopt. Dat is de default-lijst al. Maar ik had dus gezegd, kies niet voor de kleinste, kies iets groters. Maar als het goed is, als jij ze selecteert,
Nou, op zich, dit is wel natuurlijk dus sowieso groter.
welk component is dit? Dus een, is het, ja,
Gewoon, wat neem je soms als een ontkoppelsteetje?
waarom heb je geen viewer? Dat is wel raar. Bij mij laat hij gewoon een rechts onderin laat hij een dingetje zien hoe die eruit ziet. Dat is wel raar. Gaat het lukken?
Nee, we moeten moet nou bij de PCB of wat? Ik heb nog gekeken.
Ja, oké. Heeft deze een footprint?
Weet ik niet.
Dubbelklik er eens op.
Zo.
Ah, wacht even. Even 1 keer op escape. Ja,
En nog dubbelklikken?
ja. Deze heeft geen footprint, dus die moet je even klik hier eens op.
Ja.
Eentje daaronder.
Hier?
Dan kan je hier uit library.
Library?
Die, nee.
Oh.
Even hier klikken. Een tekstvlakje. Dan op dat symbooltje ernaast. Ja. Dan kan je hier eventjes een footprint selecteren van hoe ziet dat ding eruit.
Ik weet niet eens wat ik geselecteerd heb. Maar zo werkt dat dus.
Nou, je moet, de schema-editor is vooral van hoe zit alles aan elkaar geknoopt.
Ja.
En in de schema-editor zeg je ook welk component je dus hebt,
Ja.
maar ook hoe de footprint van het component eruit ziet.
Die moet je meteen mee.
Die kan je er het beste meteen ingeven. Je kan ook eerst de schema maken en daarna alle footprints goed zetten.
Dat hij dan zegt van dit is een IC met dat nummer en dat hij dan zelf dat wijzigt.
En, nou ja, de grap is, elk component heeft ook zijn eigen, die heeft meestal meerdere manieren dat ze verkocht worden. Je hebt als je zo'n microprocessor hebt, zo eentje die ik er straks erop heb laten zien. Je hebt de pinnetjes aan de buitenkant. Die heeft dus ook een footprint met pinnetjes aan de buitenkant. Maar diezelfde chip wordt dus ook verkocht met balletjes aan de onderkant. Diezelfde chip wordt ook verkocht met through hole. Precies. Dus je moet het programma wel vertellen welke variant je gebruikt. Dat zoekt hij niet voor je uit, gelukkig. Ah, kijk, precies dat.
Ja, nee, dit gaat wel. Hij staat er zo beneden.
Geen idee, maar je kan wel de grid size aanpassen dat hij wat...
Doe ik dat goed of?
Ik
wil even uitgaan en doe ik vanaf 0.
je hebt een resistor geplaatst.
Bijvoorbeeld hier,
Ja, ja, dubbelklik eens.
En dan
Ja, gewoon dubbelklik erop.
klik erop.
Dan ga je hier naar footprint. En dan komt hier een symbooltje bij.
Hier ga je naartoe.
Ja.
Klik hierop.
Ja, precies. En dan kan je inderdaad hier eventjes eentje uitzoeken die een beetje ding. Maar je hebt een resistor through hole. Klopt dat?
Ja, bijvoorbeeld.
Nou ja, dan klik eens hierop. Gewoon even eentje. Dan kan je hier even gewoon eentje uitzoeken die er een beetje op lijkt. Van hoe je die gaten wil hebben.
Ja, precies.
En dat is jou.
Dat kan maar, ja, precies. We gaan een beetje welke waar dat is en wat.
Ja, precies.
Goed voorbeeld heeft niet zo gek geluid.
Ja?
Dus dan
Ja? Dubbelklik. Ja.
zie je het klaar.
En dit is een tekstvlak, dus als je hem ergens anders wil hebben, kan je hem ook kopiëren en plakken, zeg maar, in een testvlakje.
Oké.
En dan kan je gewoon, ja, precies. Ja, oké. Even op oké drukken. Precies.
Hier gewoon weer uitpakken.
Ja, precies.
Oké. En dan moet ik een bij die leds ook doen. Zo.
Ja.
Wat is
Ja.
het hier nou fout nou? Want dat krijg je waarschijnlijk met de verbinding.
Zoom eens iets in.
Huh?
Als je het componentje draagt, gaat hij dan mee? Is hij naar beneden bijvoorbeeld of aan?
Nee, dus er zit dus
Oh, nee. Ik denk, doe maar iets omhoog.
Oh, hier.
Ja,
Het lijntje moet
het lijntje gaat even zo.
Dus die kan ik nu.
Ja,
En nou
precies.
kan ik
precies.
direct weer naar beneden.
Ja.
Oh.
Ik weet niet dat het erg was trouwens. hoor.
Nee, maar het ziet er niet zo mooi uit.
Ja.
Oké, dan moet ik hier eigenlijk hetzelfde. Sorry, dat is dubbel.
Precies.
Ja,
Even,
hetzelfde. Ja.
even de footprints ingeven en daarna dan kan je dus...
Dan moet ik hier roulette.
Dus een LED through hole dus. Maar je hebt ook LED SMD als je hem erop wil...
precies. Ja, ik kan even een grapje doen.
Goed bezig. Lukt. Oh. Yes. Oh, sorry. Yeah. Go to if you find the component online, like on Fresnel, or if you have a component for like Mouser or something, there's usually a download button for the footprint and the symbol. And with the symbol and footprint editor, you can load those in. But if you can't find the component anywhere, you can make your own. If you want to make it yourself easy, find a component that already looks like your component, copy that one, and change the names of all the pins and the data. It's probably easiest. Yeah. I'm going to spread these to the other table as well. Otherwise, sorry.
Thank you.
Je moet ook eerst een netlist van gemaakt worden voordat je je PCB-editor kunt gaan editen, toch?
Nee, niet per se, maar je moet wel de footprints goed
Ja,
hebben.
dat hebben we net gedaan.
Wow,
Ik heb net de
footprints toe-
footprints geassigned.
Yeah,
Oké, gaan we in een PCB.
make sure to save. Yeah,
Open anyway.
yeah. And you can go to tools. And then update from schematic. Why is that grayed out for you? Did you save the other file?
Is dit Ctrl S?
Yeah. One moment.
Gewoon nog eventjes al deze. Nou, we hadden dus de footprints hadden we. Even kijken, wat is dat?
Footprints hadden we net geassigned.
Zoeken we de netlist.
Het schijnt dat dat niet meer nodig is tegenwoordig.
Volgens mij hoef je dat niet te doen. Maar als je deze nu sluit.
Helemaal sluiten?
Ja?
Even pauze. Locatie.
Je hebt het hoofdding van het KiCad. Die nog open?
De PCB-editor.
Ja, gewoon de hoofdprogramma. Heb jij gewoon echt de individuele KiCad schema en KiCad PCB geïnstalleerd?
Lijkt het op. Nee, ik heb echt de package KiCad geïnstalleerd.
Het zou ook een KiCad project manager moeten zijn.
Ja, ja.
Nou, deze libraries ook geïnstalleerd?
Ja.
Je hebt veel meer internet. Ik gebruik Manjaro, geen Arch. Dus misschien
Ik gebruik ook Manjaro.
Zo verder gaat Erik dan
Ja. Ja, ik weet het. Maar heel veel, bijvoorbeeld als je zo'n microcontroller hebt, die heb je ook in verschillende packages. De dikte van je lijst. Hallo? Volgens mij kan je wel ergens de standaard instellen.
Ja, dat is dus de net. Oh, wacht.
Hier ergens kan het.
Niet in de dingenslijst. Dat is niet in de schema heeft. Er zijn design rules toch?
Ja, er zijn design rules. Als je naar de PCB gaat, dan kan je dat onder tools doen. Dan kom ik zo op. Ik zal even verder gaan. Iedereen is geloof ik ongeveer op hetzelfde punt aangekomen. Op een enkeling na. Als het goed is, heb je zoiets dat het er zo uitziet. I will switch to English, sorry. This is the representation of all the components and all the footprints that you have selected. If there is something missing, it means that your footprint is not selected correctly. So go back to the schematic editor and select the correct one. This one is the one I drew. It's really simple. This pin needs to be connected to this pin. This one needs to be connected to this one, and this one needs to go here. You now need to route. You start off with dragging the components to a place that you actually want. Oh, I'm sorry, I'm forgetting one step. If you select the edge cut layer, which is on the right side, you can select a square over all of your components. That's the, you draw the edge of your PCB. It comes out for a later step. Edge cuts and then select that one. I will just for the demo, select edge cuts here, and you can drag a rectangle with this one just by mouse clicking somewhere and mouse clicking somewhere else. Over your components. Als jij hem al hebt op de edge cuts, dan niet. Ja. That's on the edge cuts, it's fine. You can go to view and then view 3D model. Yeah, that's your edge cuts. Okay. Gewoon een vierkant om je componenten heen tekenen. That's the...
Deze geselecteerd? Of moet ik dan hier ook nog dit...
Dat is de edge cut, dat is laag.
Ja.
Dus dan selecteer je die.
Oh, oké. Nu kan
Ja,
het.
en dan klik je hier en klik je daar.
Zo. Oh,
Ja.
oké.
Yeah.
Ah, oké.
That's the limit of your board that you're designing. And go if you go to view and then 3D viewer. Oh, this is touchscreen. Sorry. 3D viewer. You will have a representation of it in 3D. Okay, forgot that one part, but so now you have to, if it's correct, you will have a border over this one. And if you go to view and 3D viewer, you will have a representation of it. If you move the components to a place that you actually want it to have, you can then start routing the different paths. You can do so by pressing X and then just dragging lines over each other. And you will end up with something like this. I drag the line from here to there. You can also click in between to drag the lines somewhere else. And you basically have to make sure that the ghosty lines are all gone. You can verify if you go to view and 3D viewer again, you will have something along the lines of this, where the components will be shown, and you can see that it actually removed all of the copper, except for where you want the lines to be connected to. I will go about and help people with this. Can I turn this one off for a moment? Yes, online again. Okay, let's. Everyone is has a functional PCB, I believe. Shall we continue to the next step? I think most of us are here. Yes. Not that I know of. Maybe it's a setting somewhere. Google. I never drag my components around too much. I always just let them be where they are. I've already showed you this. Most of you can place vias by pressing V while dragging a line. You can go underneath other lines. So you go to the back of the board, and then by pressing V again, you can place another via to go to the front of the board. You can also rotate components to the back. But what you can also do is draw a zone. If you have one ground, and you want that ground to be basically everywhere where it's possible, that's actually a really good design choice. You do not want to basically drag lines back and forth until the entire plane is filled. You can just tell KiCad, I want this area to be filled with ground. So what you can do is you can drag a zone, and I will switch to KiCad for a second. If you go here and you drag a zone, it will ask you where to attach to. I don't have a component to attach to right now, but you can probably select ground, and you can basically drag a square or an area that you want to fill in. And the moment it is there, you can use, I believe it's the shortcut G, B to fill it in for you. And it'll actually trace around your existing lines, so it won't interact. It will end up with something like this, where it fills in this entire space, except for where your drag lines are. It will connect, however, to the lines that share where you hooked it up to. I can give you the presentation later if you'd like. Few design choices, by the way, if you do this. Don't make circles. These make antennas. Unless you want antennas, then do make circles. There's also a thing that the vias, that you can go to the other side of the board. Don't place them underneath like the solder pins, or don't put it on the same location as, for example, through-hole components. That won't work. Just put them somewhere where there isn't a component. You can, however, place them in the middle of a chip, for example. That works fine. Let's see. Let's KiCad. Lastly, you can ask KiCad to check your PCB under Inspect Check DRC. You can let it run, and it'll come up with a list. Like he sees problems like conflicts. You have to resolve it before you order it. Try making a zone and fill it in with ground. One of the two sides. You can also place it on the background. If you are designing a multi-layer PCB, what happens often, if you have 4 layers, then they use 2 layers for ground, and 1 for 5 volt and 1 for 24 volts, for example. That allows you to make 4 layers very easily, without having too much conflicts. For now, just 2 layers is plenty. Is het gelukt met Paints? Is het... looks good. That doesn't matter, this is fine. Anyone need help with the Paints? De andere kant. Het V. Het V.
Ja, nee, dat weet ik. Dat
Ja?
hebben we gedaan.
Ja, maar je kan hier ook zien waar je bent.
Oh, maar ik de andere kant wil zien
Ja?
als ik hem wil draaien. Dat bedoel ik eigenlijk.
Als je hem echt wil draaien, bewerken of weergave onder weergave. Weergave. Er staat hier ergens flipboard view en dan heb je achterkant te zien.
Oké, maar voor het aangeven van bijvoorbeeld dat aardvlak noem ik maar eventjes. Hè?
Ja?
Het groundvlak, dan kan ik gewoon hier doen.
Wil je met de voorkant hebben of de achterkant?
Achterkant.
De achterkant.
Moet ik hem hier draaien dus?
Ja, dan ga je hem...
Weergave.
je kan gewoon even wisselen naar de achterkant met V. Dan, of hier selecteren.
Hier zo?
Ja, selecteer maar. Ja. Dan pak je die. Ja. En dan moet je eventjes een vlak tekenen. Waar je dat ding wil hebben.
Nou, hier achter bijvoorbeeld zo.
Nee, klikken. Het is, niet drag en drop, het is klik. Dan moet je hem even ergens aan vastmaken. Nou, je hebt dus nu een 0 hangen, geloof ik. Dat is het enige ding wat aan de achterkant zit.
Oké.
Ja, klik maar. En dan op oké. En dan moet je nu eventjes een vlak tekenen, zeg maar. Dus gewoon, je tekent punten met klik.
Zo dus.
Ja, precies.
Ja.
Ja, en je moet er wel connecten hiermee. Dus je moet hem wel eventjes daar overheen tekenen.
Hier overheen.
Dus klik hem hier ergens of zo, maakt even niet uit.
Precies zo.
Nee, en dan klik je hem hier ergens of zo. Je kan vlakken in tekenen, zeg maar.
Dit bijvoorbeeld.
Ja, en dan ga je weer terug naar het begin. Ja, oké. En dan druk je op B om hem in te vullen.
Zo ja. Oké. En dan kan ik hem nu nog weer slepen als ik dat wil.
Hij is hier niet verbonden en dat is eventjes de vraag waarom niet. Geen idee eigenlijk.
Nee.
Ik kan er straks even naar kijken.
Ah,
Je krijgt het idee. Je kan vlakken mee invullen. Oké. Let's continue the stream. Ivo? Okay. If you fixed all of your DRC errors, your PCB is done. You have everything that you need. You have the headers on the right place. You've got the components on the right place. You have made a thing, a board that connects all the components together. You're ready to order. But how? Well, what you can do. Why is this on the wrong? Hello? There are several suppliers, and there's a really old way to do it, and there's a kind of a modern way. What you can do is export these type of files under file fabrication outputs. You can find several items to export the Gerber files. Gerber files is which layers you have. If you find Gerber files somewhere on the internet and you want to take a look at it, Gerber Viewer is a thing, and you can take a look at the individual layers of your PCB. And it's basically what the manufacturer needs to make the plastic. Then you have a pick and place file, which is a file that says which components you have, how many you have of them, and where they actually need to be placed on top of the board. And lastly, you have a BOM file. Sounds explosive. It's a build of materials, which is basically a list of all the components that you have with all of the data that you have to tell the manufacturer which components you actually need. So if you have a through-hole component, there's probably a through-hole resistor in there. Or if you have a microcontroller, which microcontroller, what's the footprint, etc. There's also a different way to do it, and that is just to upload your PCB file. Some websites actually provide that. I always order at GLC PCB, and you can just test that out. Let me see if I can give a quick demo. This is the one I usually use. And you can upload Gerber files here. Where is... Yeah. We can... I can just... Where is my mouse? This is one that I made just a moment ago. View 3D viewer. It's very simple. I can go to File, Export, Gerber, fabrication, Gerbers, plot, and I'll create a nice name. I can add these here. Erik, nice name. Where are my files? Here are my files. I probably need to zip them. Demo effect. Nice name. Hello. All of these. Compress, zip, open. Will process for a while. And there's my PCB. And it roughly will cost me €2 to order this thing. Just so you know, it costs roughly the same amount of money to order about 10 of them as it does to buy 3 of them, because most of the time it's setting up the machine and just pressing the enter key to make your PCB. If you want it populated, you also need to give it the other 2 files. Which items, the build of materials and the pick and place file. They can also do it for you, but the price will actually skyrocket because you have a pick and place machine and most of the cost is in setting up the machine, not actually letting the machine do its thing. If you make simple prints like this, just order it just for €2 or just buy 10 of them. Roughly the same price as 3, so you'll have a couple to spare. And just try and hand solder it. We can help you with that. We have a soldering station here. You can actually hand solder really tiny components, even microprocessors. It takes a little bit of skill, but it is doable. The nice thing about DLC PCB, and that's the next point, is you can actually make it really fancy. You can beautify your design. And that's one of the last things I actually want to address. Next one, come on. You can load in art in the PCB. You can make graphical images, but they do need to be a certain format. You can't just give it a JPEG and expect it to work. It actually needs to be an SVG. So if you have Inkscape installed, you can load in your favorite graphics. Then under path trace bitmap, you can kind of play around with the settings a little bit, see what works for you. Save it, plot it, save it, and then import it into KiCad. And that will actually allow you to put like images on top of the silk screen, but not only limited to the silk screen, the printable layer. You can also put it on the copper layer. You can also put it on the backside, or one of the options in GLC PCB is to add a gold layer on top of it. Also change the color of the PCB. So you can have a black PCB with gold printed logo on one side, and if you don't use that backside, you can make all kinds of arts with it. It's limited in colors, but just go back to the 1980s. There's a whole genre of computer games which are monochrome only, and it made the most amazing art ever. Be creative. Let me see. Also, one of the... This is completely out of sync. Let me just... yeah. One of the other things you can do, you currently used like a prototype chip board, like this one. But all of the logic actually runs in the chip itself. You don't need this PCB to run your logic. This is just nice, so it's ready-made for you. So one of the things you can do is get rid of this thing and only use the chip. But you do need to do two things. You need to power the chip. So probably look at the pins of the chip and search for VCC and ground. And you need to power it. So you might need a boost chip if you're going to use batteries to turn whatever voltage you have from the batteries to a steady 3.3 or 5 volts, depending on which chip you have. The other thing is you probably want to get your code in there. So you probably also need some programming pins as well. Just give them a header. So you can just attach an external programmer to it and put your code on top of your custom board. And of course you need to figure out an external programmer. There are guides for this online. And a lot of different ways as well. This is what I went over before. That is Inkscape. Another nice thing with KiCad, it is text-based. So you can use Git. However, KiCad does make a lot of backup files. If you haven't noticed so far, there's probably like a backup, and a backup file in your repository right now. So you might want to add that to your git ignore file. And there's also all kinds of nice tools around KiCad as well. One of the ones that I actually really like is then I have to take a look how that thing is called. There's one that exports a BOM file to a website that actually highlights the component if you hover your mouse over the board and the component on the board. I will show you a demo in a moment. Let's first finish these ones. This is still completely out of sync. These are some ideas I had. Can skip that. This is my presentation. I will try and make a demo of that one add-on I showed you before. This is it. I will stay here to help out a little bit with your designs. I've seen some of you already making your own designs, which I actually love. Are there any questions? No?
What's the benefit of the 45-degree angle for tracks?
Ja, vraag de microfoon stellen, dan kan de mensen ook.
Well, what's the benefit of the 45-degree angle in the tracks?
Simplicity. You can turn it off. It's a default option.
Okay.
It just looks nice. If you have a if you use a CPU in the middle, you can make like angel wings from lines that go everywhere. 45 degrees looks nice. It's the only reason. Any other questions? Might also have something to do with like the manufacturer process of the lines, that they don't make like too hard of curves, etc. No? Okay, well, enjoy the rest of the afternoon. I'll be here walking around, helping where needed.